Hello, welcome to our last video in a series of videos on essentials for astrological research. And we have 11 guidelines, very important essential guidelines for astrological research. And we're up to our last one. We're also going to have some conclusions and summary points. So our last guideline is to repeat the mantra. Well, not literally, of course, but keep in mind the two key ingredients for research: the effect size and the confidence level. Effect size and confidence level, those are the two things that are important. So let me give a little historical background to this. In the 20th century, researchers in many areas had a goal of statistical significance, of p less than 0.05 or p less than 0.01, to demonstrate that a relationship between predictor variables and outcome variables is very likely. You're all familiar with this. P-value, what is the probability? If it's less than 0.01, it's a great result. That was the mantra of the 20th century. That was the goal. That was the gold standard for research. It's changed. It's no longer, now in the 21st century, the focus on research in almost every area is no longer specifically p-values. The p-values are very important, but we now understand them in a larger perspective. We understand them in context. And the context in which we understand them is the effect size and the confidence level. So let's learn a little bit about this, because ultimately what we're looking for is a large enough effect size and to have good enough confidence level that it exists. That's the goal of the research. P-values are one way of indicating this, but they can also be deceptive if you don't know how to interpret them. They can deceive you about what the effect size is and what your confidence level is. So, what is effect size? Effect size is exactly what it sounds like. It's how much the predictor variable inclines a particular outcome. So, suppose that you find that there are astrological variables that predict ADHD. You collect another 20 or 30 cases of ADHD, or 100, or however many it is. You see if the people with ADHD score high on your astrosignature. You find out they do. They score higher on your astrosignature for ADHD than people who do not have ADHD. You validate that it works. Very exciting. But suppose you're able to see the astrological variables that incline to ADHD, but it's only a weak tendency. You're able to replicate the findings, but you need a large sample size to see it. So sometimes, here's the key point, sometimes you need 1,000 people. You need 1,000 people with ADHD. And you compare that to a control group, people that do not have ADHD, 1,000 of them, and then you will get a small p-value. Maybe p less than 0.01, maybe not quite as good, maybe it's only p less than 0.05. And then you collect another 1,000 people. You get p less than 0.05. And another 1,000, p less than 0.05. You need 1,000 people to see it, but you can repeat the finding. This happens sometimes in research. What this means is that you've made a scientific discovery. You have found astrological variables that raise the likelihood a person is going to have ADHD, but it's only by a slight amount. Scientifically, that's okay. That's fine. You've still validated something scientifically. But it does mean that there's a lot of work involved to replicate the finding. You have to get 1,000 cases in order to replicate it, because the effect size is very small. Very small. Here's a simple example. Suppose the average height of men in one country is 5'9". The average height in another country is 5'10". Very little difference, 5'9" versus 5'10". If I only have 100 people from one country and 100 people in the other country, I may not be able to see that 1-inch difference, but just because of random variation. I may need to have thousands and thousands of people to confirm that, yes, the average height is greater. When the effect size is small, only 1-inch difference in the height of the men, you need more people. You need what we call a larger sample size to see it. I mean, it's common sense. But if the effect size is huge, what if the average height of men in one country is 5'6", and another country it's 6 foot tall, 6 inches different? I mean, I could collect probably 30 or 40, and they're averaging 6 feet tall. These people are averaging 5'6". Even if I randomly happen to get a few very tall people from the one country that is shorter, and a few very short people in the country where the people are taller, it's still going to show the difference. And we've run a statistical test. There are tests called t-tests and other tests that show the probability. And when the effect, here's the bottom line, when the effect size is large, you will get good p-values with a small sample size. Let me say that again. When the effect size is relatively large, you will get low p-values. P-values we're looking for low p-values with a small sample size. Did I say that right? Let me say it again. I took so long to say it, I got lost. If the effect size is large, you will get a small p-value with a small sample. If the effect size is small, you're going to need a large sample to get the good p-value. It's common sense. It's common sense. So, what you're really looking at is not so much p-values, because they depend on how many people you're looking at. This is getting a little bit technical, but it's important, because sometimes people say, is 50 people enough? Is 30 people enough? Is 40 people enough? It's enough if you find a large effect size. If you find a small effect size, you will need more people. A small effect size is still scientifically exciting. It's not as useful. Suppose I want to go to a country and find tall people to play basketball. Well, a country where the average height is 5'9" versus 5'10", it's not going to really make that much difference, because there's a lot involved in being a basketball player besides height. But if I go to a country where the average 6 feet versus 5'6", wow, I definitely want to go to that country. So on a practical level, if you have a large effect size, you can use that information in useful and practical ways. But a small effect size is not as useful and practical, because it doesn't have as much impact. But if you can collect more data, large amounts of data, and replicate the finding, it's scientifically solid. I hope you followed all that. The bottom line is, what we're really looking at in research is the effect size and how confident we are. Suppose you have a small effect size and you need 1,000 people, 1,000 new cases to show a low p-value. And suppose you're able to collect 1,000 more cases of ADHD or whatever it is you're studying, and then another 1,000 and another 1,000. Maybe you get access to this huge database where they have birth times and for tens of thousands or hundreds of thousands of people, and you keep selecting another 1,000, another 1,000, another 1,000, and every time it's statistically significant, every time you repeat the study, your confidence goes up. I mean, just common sense. You've repeated it over and over and over again. So effect size can be small and confidence level can be high because you've repeated the studies so often. If you find a large effect size, it makes life a lot easier because you don't need as much data to duplicate the findings. Okay, so I want you to be aware of what it is we're finding. Let's take, for example, the very famous Gauquelin research. That Gauquelin found, supposedly, that when Mars is above the horizon, when a person is born, they're inclined to be more athletic. Well, how confident are we in that finding? We're not very confident because we're not able to collect more data, because these are eminent people, the most, greatest athletes. It's hard to collect another 1,000 athletes with birth times, given the limits of astrology's influence in the world. It's difficult. It's actually more difficult to do now than when the Gauquelins did the research because the privacy laws have gotten stricter. So we're not able to collect the data, and that means we're not able to replicate the studies. That means we cannot have great confidence in his findings. Confidence is gotten by replicating the study. The other thing is the effect size. The effect size the Gauquelins found was very small. It requires many hundreds of data to show the effect. So the results are very limited. I'm not criticizing it. It was a major breakthrough. The Gauquelins collected all this data that we continue to use for other research. It was a pioneering study, but we are way beyond the Gauquelin research. We have much more exciting research results, much more exciting things that are happening now that we're many decades past that. We have databases and all kinds of things. Our research in bipolar disorder is much more exciting than the Gauquelin findings, and should be, because we have advanced over the decades with these databases and analytical tools that the Gauquelins didn't have. Okay. All right. So this repeats what I've already said. We gain greater confidence in our findings as we're able to replicate our findings with new data. And what also helps, not as essential, but it helps if you have a good theory to explain your findings. Even if you don't have a good theory, if you can find consistent results, it's scientifically valid. It also helps to have a theory that gives us a little more confidence that we know what's going on. But it's not essential, but it helps a lot. Okay, those are the 11 essentials for doing research well. What have we learned? What are our conclusions? And what are some new conclusions we can draw from all this? Let's summarize. Let's see, I've got 3 slides, 1, 2, 3. First slide, first bit of information is that, number 1, there are research methods available that we can use. We very realistically can use these to better understand how astrology works and to make discoveries. You do not need a research institute. You do not need research specialists. I've shown you, and if you watch the additional videos as well, you'll learn even more about the specific techniques and tools. You can do the research. It's possible to make improvements in our understanding of astrology. So we don't need huge funding to make progress. Great persistence is needed in any research, but the obstacles are not insurmountable. That's just a basic, fundamental, exciting conclusion. Almost all professions have transitioned in the late 20th century and early 21st century to be very heavily evidence-based. So we're now in a world of where psychology, medicine, all kinds of fields are very heavily evidence-based. And because they're evidence-based, you may have heard this term, research is more important than ever. If you want to learn about what evidence-based means and how it can affect astrology, It's a whole area of discussion that I have not gotten into here. It's related, but basically mostly separate. I have a video about that. What is evidence-based astrology? And of course, I have a link to it as well in the description for this video. But I highly recommend that video. What is evidence-based astrology? And when you watch that video and understand what's going on with the evidence-based movement, it makes it even more important and more exciting that we do the kinds of research projects and use the research methods I've discussed in this series of videos. Another big conclusion is that by building models, we build a model and test the model. We make more progress than if we dive into testing a hypothesis too early. And so we put a lot of emphasis on the building the model and then test it. And I have another video, model building and testing instead of statistical significance, which gives more information about this. And another video called Astrology Research, Evaluating Your Findings. So I have links to both of those videos as well in the description for this presentation. But these are basic conclusions and suggestions. And finally, there is an enormous opportunity for astrology to transition from a field that is a vast tangle of ideas that never seems to ever get sorted out to becoming a field that offers reliable information. It is up to us if collectively as astrologers we decide that we have the vision, we have the willpower to make this transition. And the last additional video I'll mention is one called The Research Revolution in Astrology, which discusses that more. And of course, there's a link to that video as well, and that it is in our grasp to transition astrology to become a part of the professional world. There's all these things happening, and we have strong progress in this, that these are key issues. Understanding everything I've presented in this series of videos and what's in, especially that video on evidence-based astrology and the other videos referred to from this series. That's it, my friends. I hope this whole series of videos and also the additional ones gives you the ability to go forward and do research and collaborate with others who want to do research. Thank you very much. God bless. Namaste.